So for bone development, it's called ossification. Ossification, and there's two different types, intramembranous and endochondral. Intramembranous takes place in connective tissue, primarily in the skulls and the fontanelles, the soft spots in the baby's heads and the skull. And then endochondral ossification takes place in cartilage, and that's what makes your skeletal bones grow longer and calcify.
Sorry, go ahead.
Both types of ossification will produce woven bone that's then remodeled into compact bone, and that after remodeling the final product, the bone after all the remodeling at the final product will not be distinguishable from each other, so it doesn't matter which type of ossification occurs, you're going to get the same product. How about now? Whoa. Intramembranous ossification takes place in the connective tissue, part of the mandible, the skull bones, and the diaphysis of the clavicles. And there are centers of ossification, the little areas where the ossification actually takes place, and then it would spread from there. We'll wait for Blake. The fontanelles, we've already talked about those in our lab, those soft spots in the skull. So endochondral ossification forms all the other skull, or some of the other skull bones, part of the mandible, and then most of the remaining skulls most of the remaining bones in the skeletal system. Cartilage formation begins at the end of the 4th week of development in embryo, and the ossification then begins around week 8. It's when bone starts to develop, and some does not begin until 18 to 20 years of age also. So this picture would be an embryo at 4 weeks where you'd have a cartilage for your whole bone, and ossification would take place in the diaphysis and lengthen the bone in that direction. As it gets longer and longer, this is where we get the epiphyseal line, or epiphyseal plate right here. When it ossifies, it's the epiphyseal line. This is just closer up pictures. Growth in bone length involves interstitial growth and appositional growth. There's it always occurs at the epiphyseal plate, the growth in bone length. There's a closure of epiphyseal plate between 12 and 25 years of age. It all depends on some genetics, some nutritional factors, hormones. All are why the epiphyseal plate would close. The articular cartilage at the ends of the joints do not ossify. You're always going to have that. Now you may have calcification in there or some injuries to that articular cartilage, which would which would cause inflammation, and that's what like arthritis and stuff is when you have bad, a lot of times it's bad articular cartilage there. In the epiphyses at the ends of the long bones. Appositional growth occurs in old bone after the epiphyseal plate has closed. You still have some appositional growth there. And when you have no epiphyses, so like short bones, so you don't have an epiphyseal plate, there is still growth at the articular cartilage. The chondrocytes near the surface of that cartilage are similar to those that would be in the epiphyseal plate. So you're still going to have growth in bone length there. Here's a picture of a fracture that's at the epiphyseal plate. And so if you fracture there, it can disrupt the growth of that bone. Mrs. Marker's daughter just had a really bad break in her elbow that they had to pin and are hoping that it will keep growing there. So you can. Mhm. Mhm. They think they fixed it right. She broke her arm right by her elbow. Like it was really close. I don't know exactly. Probably. I would think so. Growth in bone width occurs when there's a blood vessel that's running right next to the bone, and your bone actually kind of engulfs it over time, and that would make the bone grow and wider in diameter. And we'd have that whole blood vessel and the bone that's going around it would create another Haversian system, another set of tree rings that you'd see. So that's how you grow in bone width. Can you tell? What?
It's like after you break something, then it will grow.
No, this would happen just naturally. Because like when you're little, you have a lot smaller round bones. And so that's how it gets wider as you grow too. Bigger round.
So this looks like a tree
trunk. The factors affecting bone growth can be determined genetically, but there's nutritional factors and hormonal factors. Some nutritional factors is calcium. You need calcium for your bones to grow. But in order to absorb calcium, you need some vitamin D, which we talked about how vitamin D is produced last chapter. If you don't get enough vitamin D and you can't absorb that calcium, you can, in childhood, it's called rickets. In adulthood, it's called osteomalacia. Means it's the same type of condition where your bones would be softer than normal. Malacia is a suffix that means softening, so osteomalacia is a softening of the bone. The vitamin C is also necessary for collagen synthesis. And if you have a deficiency of vitamin C, we've talked about scurvy. Collagen is in your skin a lot, so vitamin C is needed for wounds to heal, and it helps hold your teeth in and that kind of thing. And hormones, there's growth hormone from your pituitary gland that stimulates the interstitial bone growth and appositional bone growth, so lengthening your bone. The thyroid hormone is required for growth of all tissues. And then sex hormones such as estrogen and testosterone cause more growth to occur at puberty, but it also causes the epiphyseal plate to start to close and calcify and ossify into bone to become an epiphyseal line. So. And that's it for today.